Okay, so we're going to kind of do some application today with our problems. And again, these are 45, 45, 90, and 30, 60, 90 application problems. So here's the first one. It says the length of the diagonal of a square is 7 radical 2 over 2. What is the length of a side? Okay, so the first thing on all these problems, these word problems, is you want to make sure you know how to draw the picture. So I hope in this problem, I hope everybody knows how to draw a square. We talked about squares before. So I'm going to draw a square. Now it says the length of the diagonal of a square is 7 radical 2 over 2. So I'm also going to draw in a diagonal. I'm going to label that 7 radical 2 over 2. I know in the square that the angles are right angles. And the question's asking, what is the length of a side? Well, we know in a square, all of the sides are the same, so I'm just going to use the letter X to represent the sides. Now, as we look at this picture, can somebody tell me what kind of triangles are formed in this picture? Aiden?
45, 45, 90.
Yeah, these are 45, 45, 90 triangles because they're isosceles and because there's a right angle there. So what that tells us is we're going to utilize here our 45, 45, 90 rules. So I have the hypotenuse, much like we just did on our warm-up. We know the ratio is 1 to 1 to the square root of 2. So if I fill in what I know, the sides are going to be my x's. And the hypotenuse here is 7 radical 2 over 2. Now, when I go ahead and solve here, I cross multiply it. 1 times 7 radical 2 over 2 is 7 radical 2 over 2. And then x times radical 2 is just x radical 2. Now, if I want to solve that for x, I'm going to divide both sides by radical 2. Now, to help you with this, I want you to think about, because we've got a fraction over here, dividing a fraction by something else makes it complex. So what I want you to think about to help you is when I divide by radical 2, that's really like multiplying by 1 over radical 2. So I multiply by 1 over radical 2. And those are going to cancel, leaving me with x on the right side. Now I've got a radical 2 on the top and the bottom. Those cancel out. And I'm just left with 7 over 2. So in this problem, because they've given us the diagonal in kind of fraction form, you could leave it in this form 7 over 2, or we could go ahead and divide it out in our calculator. We know hopefully that 7 over 2 would be 3.5 or 3.5. 2 goes into 7 3 times with 1 left over. And again, 7 over 2 or 3.5. So in this problem, here's what it says. It says, what is the length of a side of an equilateral triangle whose altitude has a length of 14? So again, first thing we want to do is draw our picture. You know, I know a lot of you like to do your work or do your problems without writing anything down. Okay, these aren't problems you're going to be able to do without drawing the picture. So we want to draw an equilateral triangle. Remember, that's a triangle with three sides all the same. Maybe a new word for some of you, the word altitude. If you think about the altitude of a plane, basically we're talking about how high up is the plane? How tall is the triangle? What's the height? Another word for altitude. So I'm going to draw in my altitude. The altitude of a triangle also always forms a perpendicular with the base. So it makes a right angle. We want to know here what's the length of the side. So again, I'm going to put X in here for all three of the sides. And they're telling us that the altitude is 14. Hopefully, as you look at this picture, again, equilateral triangle, what kind of angles do we have in an equilateral triangle? Anybody remember? Well, all three of the angles are going to be exactly the same. Go ahead.
I think 60.
Yes. So we've got a 60-degree angle, 60-degree angle, and the top angle is 60. When we drop the altitude, it splits that angle in half and makes that 30. So hopefully you notice now we've got a 30, 60, 90 triangle. We're trying to find the hypotenuse of the triangle. If I list my ratio, remember 30, 60, 90 is 1, square root of 3, 2. Well, in this picture, the 14 is opposite the 60. So in my ratio, where's that going to go? Aiden?
Under the root of 3.
Yeah, so we're going to put 14 here. We know the hypotenuse is x, so that's got to go under the 2. We really don't even need to worry about the 1 because we don't need to find that length. So we're going to do radical 3 times x. 14 times 2 is 28. Oop, need to move it up, sorry. And divide by radical 3. So x is 28 divided by radical 3. Now, by the way they've given us this problem, again, we could leave it as 28 over radical 3, but I'd say this would be a good one to go ahead and put it into your calculator and determine what the value of the hypotenuse would be since they tell us the height is 14. So 28 divided by radical 3. And hopefully here you get x to be 16.2.